Hello, it's Mrs. Weir, and I'm here to share with you the Week 2 Chemistry Lab activity. So if you have logged into Blackboard, in the Week 2 folder, here's what you'll notice is the two things that you need to complete this week for your points. One is the actual virtual lab, the density virtual lab. It itself has two parts to it. And the other part is, instead of a quiz, you're going to be turning in a data sheet. The data sheet looks like this. Here's the data sheet. Looks like this, and you have the option of either printing this data sheet and handwriting your answers. If you do that, you'll need to upload a photo of the sheet, or you can actually type in your answers into the sheet itself. So I would recommend that you do the virtual lab first before you do the data sheet, because the questions on the data sheet, they go with the virtual lab activity. So as I stated before, this week's lab activity has to do with density. Oh, hold on. There we go, I fixed my camera angle. But as I mentioned before, this week's lab has to do with density. And so the formula for density is the mass of an object over the volume of an object. If you're dealing with a regularly shaped object, like maybe something that has a square shape, like my little box of raisins here, all right, I always have a snack handy, but my little box of raisins here has a regular square shape. Or if you're dealing with something that has a, a regular shape like a sphere, something like a little ball, you can use a ruler or you can use a formula to calculate the volume. So for example, if I was trying to calculate the volume of this little tiny tennis ball right here, I would use the formula of 4/3 pi r squared. I'd have to determine what the radius of my tennis ball is, and then cube that, not square it, cube it times pi times the fraction 4/3. If I was doing, trying to determine the volume of my little box of raisins here, well, because it's nice and flat and square shaped, I could actually use a ruler, just a regular ruler, and measure the three dimensions, the height, the width, and the length of my little box of raisins, and I could tell what the volume is that way. I could measure it with the ruler in centimeters and multiply those values, and I'd get centimeters squared. The nice thing about that is that centimeters squared is equivalent to a milliliter. In fact, that's actually the definition of what is a milliliter. It's something that's 1 centimeter by 1 centimeter by 1 centimeter. Isn't that nice? So if I was trying to determine the volume of my little box of raisins using my ruler, if I measured it to be 5.4 centimeters by 1.5 centimeters by 1.5 centimeters, then my calculator would tell me that the volume is 12.15 centimeters cubed. Well, if I need to round that to two significant figures, because when I'm multiplying, I have to match the lowest number of sig figs, and it so happens that my answers have 2 sig figs in them. This one has 3 sig figs, so if I need to round it down to 2 sig figs, 12.2 won't work. I would actually have to report that is 12 mLs, and that would be in 2 sig figs. And so remember that there's no conversion between centimeters and milliliters. You can just erase one and write the other, because 1 centimeter cubed equals 1 milliliter. You might see this information on your data sheet, where you're given the dimensions of a regular shaped object, and you're told the height, the width, and the length. And then you multiply those numbers in order to determine what is the volume of that object. The mass of an object, well, the easiest way to do that is with a balance, okay, an electronic balance. And you'll either do that on, or a scale. I still say balance because Mrs. Weir's old school. But you could do that in the laboratory just using one of those digital scales. But volume for something that's regularly shaped, one way that you could do it is using a formula, or if it's something, kind of boxy, you can measure the dimensions using a ruler. Well, what if you have something that's irregularly shaped? Okay. If it's irregularly shaped, well, you can do this by measuring what we call using volume or water displacement. So for example, let's say you had your graduated cylinder and it contained 20 mils of water. you could actually take your oddly shaped object and drop it into the water, but it's got to be completely submerged, okay? It can't be floating. It's got to be completely submerged. The reason it needs to be completely submerged is because water displacement means that when the volume of the object is down here, it's going to displace the same amount of water that it takes up. So the volume of water that is displaced is equal to the amount of, or to the volume of the object. So let's say, for example, this snazzy ring that I'm wearing right here, it would be hard to measure the density because it's, round in some areas and it's flat in other areas, and then it's got this big hole in the middle. How do I account for that? Well, you could get a graduated cylinder, okay? And this is basically what I have right here is a little graduated cylinder, and when I drop the object into the cylinder, okay, and when it's completely submerged, then the level of the water is going to change, and I have to tip it sideways. The level of the water is going to change equal to how much room my ring or that irregularly shaped object is going to occupy. One of your lab questions on both the handout and in the sheet, one of your lab exercises is going to have you measure the volume of stuff by water displacement. So putting something in a graduated cylinder. Well, what happens if you have an object of known density and you have a solution or liquid of unknown density? Can you use a known to help kind of estimate or even calculate to some degree an unknown? And the answer is yes. In fact, this is one of your lab activities. You'll be given a cube, a virtual cube, that's going to have a particular mass, a particular volume, and they'll even tell you what the density of this cube is. Then they'll have you fill a graduated cylinder with different solutions. So you might put something like, I have in here 25 mils of this unknown density, this solution. Then you're going to take your cube, which you do know stuff about, and you're going to drop it into the water. Observing the behavior of the cube in the water will tell you an approximation of the density of that liquid. So if the cube floats, you know that this cube and this solution, their densities are not the same. So if the cube floats, then that means that this is less than the density of the liquid. But if the cube kind of suspends itself, so it doesn't really sink and it doesn't really float, if it's suspended, then that means that the cube and the liquid that's floating have the same density. But if the cube sinks all the way to the bottom, then you know that the cube is more dense or has a higher density than the liquid. And there's a cool little part of the lab where you do that. So on your screen, this is the beginning part of this week's lab activity. Notice that you'll need to budget somewhere between an hour to probably an hour and a half in order to complete both parts. You don't have to do them at the same time, but you do need to budget a total of 45 minutes to do part 1 and 45 minutes to do part 2. So this lab takes a little bit longer than last week. At the beginning of the lab, this explains one more time the difference about how you can determine the relative density of something based on how the object behaves. Does it float? Does it sink? Or does it kind of suspend somewhere in the middle? So here is your lab activity. Here's your simulator.